Now in this class we are going to discuss few more problems on singular value decomposition. And let us write, I am writing the second problem because we already discussed one problem in the previous class. Okay. Find a singular value decomposition of A equals 1, minus 2 and 2, minus 1, 2 and minus 2. Yeah, number of rows is 3, number of columns 2. This is a rectangular matrix. You usually applying singular value decomposition, they are giving a rectangular matrix. That is the beauty of this. Even the rectangular matrix is possible to convert to decompose into product of 3 matrices. Okay. Solution. First you find out A transpose into A. A transpose is 1 minus 1 row into column. Therefore, my 1 minus 1 row into column minus 2 to 2 minus 2 into A. What is A? 1 minus 2, 2 and then minus 1, 2 and then minus 2. Yeah, you multiplied this, what we get row into column. 1 minus 2 minus 2 is plus 4 we get 9. 9 and then you take row into second column minus 1, minus 4 and then minus 4. What we get actually? Minus 9. Okay. And then come to the second row, minus 1, minus 4, minus 4. What we get? Minus 9. Minus into minus plus 1, 2 into 2, 4, minus 2 into minus 2 is plus 4, we get 9. This is a matrix, square matrix we get from A transpose into A. What's our next step? You find out determinant of A transpose A minus lambda I equal to 0. Now what is my I? Is the order of the matrix is 2, therefore I have to take 2 cross 2 identity matrix. From that what we get? Determinant of 9 minus lambda, minus 9, minus 9, 9 minus lambda equal to 0. Now you solve that, what we get? 9 minus lambda whole square minus of minus 9 into minus plus 9 plus 9 square 81 equal to 0. This is I am going to write 9 minus lambda square minus 9 square. A square minus B square. What is A square minus B square? A plus B. 9 minus lambda is A and B is 9. The another thing is what actually? A minus B. 9 minus lambda minus 9 equal to 0. Then what are the values? What are the thing? Now here we get 9 minus lambda and 9 minus lambda. See, observe carefully here. Simplify that. 9 plus 9 means what? Actually 9 plus 9 is what? 18. 18 minus lambda equal to 0. Plus 9 minus 9 is cancelled. Minus lambda equal to 0. Therefore, finally we get lambda is equal to 18 and lambda 1 and lambda 2 is equal to 0. How many roots are expecting? 2, because order of A transpose into A is 2 cross 2. The next you have to find out the corresponding eigen vectors. Now first you write the matrix, but the eigen matrix is, take the matrix of this 9 minus lambda minus 9 minus 9 9 minus lambda. It's a matrix. It's a 2 cross 2. They take only 2 x1 x2 must be equal to 0 0. This is my star. Now we have to take one by one eigen values to find out corresponding eigenvector. Put lambda is equal to 18 in star. Yeah, what we get? Matrix of 18 minus 9. What we 18 minus 9, what we get actually? 9. Now we get my 18 9 minus 18 minus 9. This is minus 9. Minus 9, this is also minus 9. We get all the things are same. X1, X2 must be 0. Okay. From this, from these two, what's the equation we get? Both the equations are same. 9x1 minus 9x2 equal to 0, minus 9x1 minus 9x2 equal to 0. That implies 9x1 is equal to 9x2. That implies x1 equal to x2. That can also be written as 1 divided by 1. It does not matter. Therefore, one eigenvector is 1 1 is the eigenvector. And next try to find out another eigenvector. Put lambda is equal to 0 in star. What we get? Put lambda is equal to 0. What we get? 9 minus 9 minus 9 9 and then x1 x2 0 0. Yeah, write the equation. We get both the equation same form. 9x1 minus 9x2 equal to 0. Minus 9x1 plus 9x2 equal to 0. Now you simplify that. Now here, now we observe carefully for the thing is x is equal to 0. What we get actually x1 9 is equal to x1. Yeah, x lambda is equal to 0. Then we get 1 1. Yeah. Lambda is equal to 0. No, I did here mistake. 1 minute, I'll explain. That implies x1 is equal to x2. That implies x1 by 1 is equal to x2 by 1. What we get actually? x2 is equal to 1 minus 1. Okay. Now here, both are negative, right? Observe carefully. I'll take one term in the right hand side. What we get? Minus sign. Observe carefully. Otherwise, first you multiplied by divide by minus 9. What we get? x1 plus x2 equal to 0. Divide by minus 9 here. What we get? x1 plus x2. Then what we get actually minus. Therefore, here we get 1 root 1 is 1 minus 1. Yeah, I did one small mistake here. Both are having negative sign. Divide by minus 9. x1 plus x2 equal to 0. Simplify that, we get x1 minus equal to minus x2. Therefore, 1 minus 1. These two are the eigen values, eigenvector. And then verify what happened in a product of x1 comma x2 is nothing but x1 transpose into x2. x1 is 1 1, x2 is 1 minus 1. What we get actually? One should take, this is transpose means what? This is become row. 1 1, okay, in another one minus 1. Simplify that, 1 minus 1 is 0. Therefore, the set of vector x1 x2 is an orthogonal set of vectors, non-zero vectors. Therefore, this form a orthogonal basis, but we need normalized. Therefore, what is B1? x1 divided by norm of x1, x2 divided another this norm of x1. What is norm of x1? That's very easy. I am doing it in orally. Square root of what is my x1? This is my x1. Square root of 1 square plus minus 1 whole square is root 2. Therefore, divide x1 with root 2. What we get? 1 by root 2. And minus 1 by root. And the another V2 is nothing but x2 divided by norm of x2. Here also norm of x2 means square root of 1 square. Here we get 1 comma 1. See, observe here x1 denominator 1, x2 denominator is 1. Therefore, 1 comma 1. Okay. The square root of see, this is then we get actually that must be 1 and just a minute. Taken here you have to take minus 1, here you have to take plus 1, but both are must be same only, it does not matter. But I interchange x1 and x2 interchange. This is x1, this is x2. That's all. Okay. Now is correct. Now once you take this square root of 1 square plus 1 square, what we get? 2. Then we get 1 by root 2 minus 1 by root 2. Here I have taken minus 1, actually 1 minus 1. Even though find out transpose, here minus 1, this is plus 1. We get 1 minus 1, we get 0. is an orthogonal non-zero vector only. Don't worry about that. And then suppose I did anywhere small mistake, you please take care for that. Okay. In the next step, what we are going to do? Now we are going to do is we have to write capital V. Capital V is nothing but V1, V2. What is V1? 1 by root 2. I did norm of x1. If you want, I'll write norm of x1 here is square root of 2. And norm of x2 is nothing but square root of 2. Because square root of 1 square minus 1 whole square. This also 1 square. 1 square we get 2 only. Okay. 1 by root 2. What's the minus 1 by root 2? Okay. And then 1 by root 2. 1 by root 2. 1 by root. Okay. This is a value for this. This is 1 by root 2, 1 by root 2. Okay. This is my V1 and V2. We get V. Next you find out sigma 1. What is sigma 1? Root of lambda 1. What is lambda 1? Root of 18. 3 root 2. Sigma 2 is nothing but root of lambda 2 is nothing but 0. And next try to write what is my D. D is nothing but only one value. What is that? 3 root. Therefore, I'll write like that, 3 root. Keep in mind, that's why I'm solving this problem on the board. Now, only one non-zero singular values. What is that? 3 root 2. This is, we can't write in the next row. Only are framing a diagonal matrix whose diagonals are non-zero singular values. Delta. How many rows you have? 3 rows. But here having only 1 row. Therefore, make it another 2 rows are 0. This is delta. Okay. Next, I have to find out U. While finding a U, I find out AV1. What is AV1? A is 1 minus 2, 2, minus 1, 2, minus 2 into V1. What is V1? What we have taken V1? 1 by root 2 minus 1 by root 2 is V1. Okay, fine. You multiplied this, what we get? AV1, row into column. 1 by root 2 minus into minus plus 1 by root 2. What we get? 2 by root 2 means root 2. Next you multiplied with the second row. Minus 2 by root 2 minus 2 by root 2. What we get? Minus 4 by root 2. Minus 2 minus 2. What we get? Minus. Now what we get actually, if you suppose you simplify this, minus 2 root. 2 root. Okay. And next you have to take the next value, second one. 2 by root 2 minus into minus plus 2 by root 2. What do we get? 4 by root 2 means 2 root 2 is nothing but my what is actually root 2 minus 2 root 2, 2 root 2 is my AV1. Okay. Once we get AV1, I am not finding AV2 because I am required number of rows is 3, I am required how many unit vector. I will explain this part, carefully observe this. Next step is very, very important. Next step is very, very important. In this step, what we are going to do here in this step, I am not finding AV2. Why? Because we are finding U1 is AV1 divided by sigma 1 and U2 is nothing but AV2 divided by sigma 2. But we can't find out U2 because sigma 2 is 0. What we get? AV2 divided by sigma, AV2 is not equal to 0, divided by sigma 2 0. Non-zero divided by 0 is infinity we get. We are expecting finite value. Therefore, but we need 3, but it's possible to find out one only unit vector. What's the one? U1 must be equal to AV1. What is AV1 is nothing but root 2 minus 2 root 2 and then 2 root 2. AV1. Okay. By sigma 1. What is sigma 1 value? 3 root 2. Yeah, is nothing but you take inside the bracket 1 by 3 minus 2 by 3, root 2 cancel and then 2 by 3 is my u1. Yeah, 1 by 3 minus 2 by 3 and 2 by 3 is my u1. But I need two more. I need two more u2, u3. But keep in mind, these what we are finding two more, that must be orthogonal to u1. Therefore, we are using one formula, u1 transpose into x must be equal to 0. u1 transpose into x is 0 means what are the vector we are taking, we are finding a vector for using this formula, we are finding other two vectors u2, u3 that must be orthogonal to u1. Therefore, keep in mind, whenever you don't get it, number of unit vectors must be equal to order of the given number of rows of the given matrix. How to proceed? We are using one formula. This is a constraint optimization formula. u1 transpose into x is equal to 0. Now, u1 transpose is x. Using this, we are finding other two vectors. Definitely, other two vectors are orthogonal to this. Which one? u1, because we are finding based on u1. Definitely, we are what we get other two vectors is orthogonal to u1. Now, what is u1 transpose into x is nothing but u1 transpose means u1 becomes root 2 1 by 3 minus 2 by 3 2 by 3 is because transpose means row into column. X is having how many unknowns? 3 unknowns, x1, x2, x3. 3 unknowns because they are having 3, therefore we are taking 3 only, x1, x2, x3. Simplify that, x1 by 3 minus 2x2 by 3 and then plus 2 x3 by 3 equal to 0. Now 3 is common, what we get? x1 minus 2x2 plus 2x3 must be equal to 0. But here we get one equation. How many unknowns you have? 3 unknowns. Therefore, what I am going to do here, I will put x1, x2 must be equal to k and x3 is equal to k1, x3 is equal to k2 because I need, you have one vector, I need two more vectors because how many rows you have? 3 rows, therefore how many unit vectors I need? 3 unit vectors, therefore I will choose 2 unknowns, x2 is k1 and x3 is k2. What we get? x1 minus 2 k1 plus 2 k2 must be equal to 0. Okay. Now, see, you know that in the first module, suppose is a ordered basis 2. What are the standard vectors are? 1, 0 and 0, 1 are the standard vector with the dimension 2. With the 2 components, what are the standard vectors? 1, 0, 0, 1. Why I am choosing standard vector? Always standard vectors form a basis. For safer side, we are, whenever you want the values, we are choosing standard vector values. Here having 2 components, what are the 2 standard vectors are? 1, 0, 0, 1. Therefore, now first you put k1 is equal to 1 and k2 is equal to minus 0. First one, where in double star, in star, double star, what we get? x1 minus 2, yes, k1 is 1 and then what is what about that another value? Then once we get that, just a minute, and then we are putting the value for x2 is what is thing, first try to simplify this. Put this is a value. Once you put k1, k2, what's first I am writing what I choose the value is correct. What is x1 is 2k1 minus 2k2. Okay, fine. Okay. Now I choosing the values are what? K1 is equal to 1. Put, this is take it as some other notation like that. And then k2 is equal to 0. In this, what we get actually, x1 is 2, 1 and my 0, what we get 2. Therefore, what is a vector? This implies I am taking that vector is nothing but 2, 1, 0, 2, 1, 0. Next you put K1 is equal to 0, K2 is equal to 1 because standard vectors. Where I am going to put? In RMR. Where? This. We get x2 value, x1 value. 0 minus 2. That implies what is W2? I am taking W2. Why? After that I am explaining why we are taking this minus 2, 1, 0, 1. Minus 2, 0, 1. Now we get how many? 2 more vectors. Before move to the next step, I am going to explain this part. Here number of rows is 3, but here we get only one unit vector, need 2 more. Therefore, using the formula U1 transpose into X. Once you use this formula to find out what are the vector we get, definitely is orthogonal to U1. From this formula, we get one equation in terms of 3 unknowns. But now what I did, I choose 2 things, we get automatically another one value. Therefore, now I am choose x2 is k1 and x3 is k2. Now is a 2 components. In the 2 what are the standard vectors? 1, 0, 0, 1. Now you know the standard vectors of form a basis in module 1. That's why I choose the standard vector values 1, 0, 0, 1. Therefore, I take k1, k2 value 1, 0 and then 0 and 1. From that we get 2 sets of vectors. Now I have to verify whether these 2 vectors are orthogonal to U1. I told already definitely is orthogonal. Yeah, 100% is orthogonal. Now take inner product of U1 comma W1. Is U1 transpose into W1. U1, what is U1? This is my U1, 1 by 3 minus 2 by 3, 2 by 3 into, I don't have a space, I'll write it in next step. Yeah, that value is nothing but what? 1 by 3 minus 2 by 3 and 2 by 3. What is my W1? W1 is 2, 1, 0. You multiply that. 2 by 3 minus 2 by 3. 2 by 3 minus 2 by 3, what is that? Value 0. Next, this is inner product of U1 comma W1 and also find out inner product of U1 W2. Definitely this also 0 because we find these 2 vectors based on U1. 1 by 3 minus 2 by 3, 2 by 3 of minus 2, 0, 1. You multiply that minus 2 by 3, 0 plus 2 by 3. What we get actually? 0. Now, W1 and W2 are orthogonal to U1, but observe W1, W2 is not orthogonal. What is that? W1 transpose. What is W1 transpose? Is nothing but W1 transpose into W2. 2, 1, 0, minus 2, 0, minus. 1. Multiplied minus 4, 1 into 0, 0 and 0. Means it's not equal to 0. It's not equal to 0. We get not equal to 0. We get minus 4. This shows that these 2 vectors are not orthogonal. But what are the vectors you have? U1, U2, U3 must be orthogonal. You must be normalized. Now, why this thing is facing here? Why? Because in the first problem here we get directly AV1 by sigma 1, AV2 by sigma 2, directly we get U1, U2. That is normalized. That both U1, U2 are orthogonal. But here is not orthogonal. Why? Because we find out W1, W2 based on U1 definitely is not orthogonal. But in the previous also I had to verify it. U1, U2 definitely orthogonal. That's why I skipped that. Because whenever you are finding, keep in mind, U1 or U2 using AV1 by sigma 1 formula and AV2 divided by sigma 2 formula, in that case definitely inner product of U1 comma U2 must be 0 if you want to verify it. But here we are not finding U2 directly. From U1 you find out other 2 vectors W1, W2. These 2 are orthogonal to U1 but it's not orthogonal to itself. Now I make it to orthogonal vectors. Therefore, using which one? Gram-Schmidt process. You know how to take Gram-Schmidt process, okay? Now, the first vector I am going to take say some y, y2 because is already is there, y1. y1 is nothing but my w1. What is my w1? 2, yeah, 1, 0, okay. What is y2? From the Gram-Schmidt process, Schmidt process. You have to convert orthogonal. In the previous I am not verified, definitely is orthogonal. Y2 is nothing but W2 minus inner product of Y2, inner product of what is the value have W2 only, yeah, W2 comma Y1 divided by inner product of Y1 comma Y1 into Y1. Using this formula, I am trying to find out what actually Y2. Okay. First you find out inner product of W2 comma Y1 is nothing but W1 transpose. What? Because it's a column. W1 transpose is what? Minus 2, 0, 1. What is into Y1? Y1 is nothing but 2, 1, 0. 2, 1, 0. Multiply that. What we get? Minus 4. Yes. Now observe carefully. Now what's the value for this? Minus 4, 0. Yeah. We get only minus 4 value. Here what we get actually? We get that value is nothing but minus 4. Yeah. Once we get minus 4, next you find out the value of inner product of Y1 comma Y1 is nothing but Y1 transpose. Just you take square of each of the value. 2 square, yes, 1 square plus 0 square. What we get actually? 4 plus 1 is 5. 4 plus 1 is 5. Yeah, I did orally because you multiply twice means 2 square plus 1 square plus 0 square. We get 4 plus 1 plus 0 is 5. And next you find out from Y2, yes, W2, what is my W2 is minus 2, 0, 1 minus of inner product of that. What we get? Minus 4, we get plus 4 by 5 into Y1. What's the Y1 here? 210. Yeah, you simplify for this. Once you simplify, after the simplification, what we get? Actually, minus 2 by 5, 4 by 2 by 5, 4 by 5, 0. Just you simplify that. First you take 4 by 5 inside, we get 8 by 5. Take LCM, minus 10 plus 8, what we get? Minus 2 by 5. This is 0, therefore we get 0 plus 4 by 5 is 4 by 5. And then 1 plus, this is 1. 1 plus 4 by 1 plus 4 by 5 into 0, what we get actually? 1. Therefore minus 2 by 5 plus 4 by 5. Just you multiply 4 by 5. 8 by 5, 4 by 5, 0. Add it. We get minus 2 by 5, 4 by 5 and 1. That's all. Now this Y2. Now I have to verify these two vectors are orthogonal. Inner product of Y1 comma Y2. Inner product of Y1 comma Y2 is orthogonal or not, I have to verify it. Then once you verify this orthogonal or not, now definitely these two are orthogonal after this step. Now 2, 1, 0 is a transpose into minus 2 by 5, 4 by 5, 1. Multiply that, minus 4 by 5 plus 4 by 5 plus 0. What we get actually? 0. Then Y1, Y2 are orthogonal. Once these two are orthogonal, next we have to find out what is a normalized vector u1, u2, u3. u1 is u1 itself because we are not touch u1. Use the general formula AV1 by sigma 1. Okay. u2 is nothing but y1 divided by norm of y1. Okay, I have to do that normalization. And also u3 is nothing but y2 divided by norm of what about that? Y2. Why? Because what are the vectors are orthogonal here? U1, Y1, Y2 are orthogonal vectors. Now I have to normalize for this. Not necessary to normalize because we get this from the direct formula. But we are finding these two different way. That's why beginning is not orthogonal. Next we convert orthogonal and then I have to normalize. You know that in Gramsci-Schmidt method we get orthogonal vector. Y1, Y2 we get orthogonal from the Gramsci-Schmidt process. But after that, before move to the next step, we have to normalize. Then only we get normalized vector. No, you recall that we discussed in the Gram-Schmidt process. U1 equals, what's a vector? U1, we already know that U1 vector is 1 by 3, minus 2 by 3 and 2 by 3. And then U2 is nothing but norm of Y1. What's Y1? This is square of the 2 square plus 1. What we get? Norm of W1. What is norm of Y1? Square root of 2 square plus 1 square plus 0 square. We get root 5. Then I have to divide 2 by root 5. Yes. 2 by root 5, 1 by root 5 and 0. Because 0 by root 5 is root 0 only. And next you take U3. Take norm of Y2. What is now Y2 value? This is my Y2 value. Yes. This is my Y2 value. Square of that, square root of 4 by 25. 4 by 25 plus root of square of 4 by 5 is 16 by 25 and then 1. Take LCM and simplify that. Finally, we get the value of whatever that U3 is minus 2 by 5, 4 by 5 and 1. V3. V3 of 5 we get different, not for this, is actually minus 2 by root of 45 and then 4 by root of 45 and then 5 by root of 45. Yeah. What we are going to do here, square root of this we have to calculate. Square root of this. What's Y2? Y2 is this norm of Y2. What is norm of Y2? 2 by square root of minus 2 by 5 whole square is nothing but 4 by 25, 16 by 25 and 1. Take LCM and simplify that, we get this. What is minus 2 by what about that root of 45, 4 by root of 45, because we have to find out norm of V1 and V2 and V3 value. You please try to understand that. You try to find out this value. You know V3, what is my V3 is minus 2 by 5, 4 by 5 and 1. You take that square root of the each of the value and simplify that. What we get? Root of 45 we get. Then if you want to check it out for that, how we get that, then after we get this, simplify that, so what about 20, 21 divided by 5 and then the root of 21, then simplify that, we get this answer. After divide this, all written, what is a norm of Y2 is square of sum of these values. Divide Y2, we get this. Yeah. The next step, after this step, these are the U1, U2, U3. Before move to the next step is very easy. What is you framing U? What is U? U1, U2, U3. I am not going to do that part. You only do it. And next you verified U, delta and V transpose. That gives us A. That also you know that in previous. Why I use discussing this problem here is one of important problem. Now after we get what about eigen vectors, now we have to observe eigenvalues corresponding eigenvector, then they are orthogonal, and then we have normalized, we have taken V1, V2, V3. Okay, fine, you know D also, you take delta. But while finding sigma 1, sigma 2, sigma 1 is 3 root 2, but sigma 2 is 0. Only we get U1. What is U1? AV1 divided by sigma 1. But we are having 3 rows, but you get only one U1. But I need 2 more. Therefore, what we are going to do, what you get U1, you take the formula U1 transpose of x is equal to 0. Suppose use this formula, then we get, what are the 2 vectors we get? I need 2 more vectors, that's why I taken 1, 0, 0, 1, taken x2 and xj as k1, k2. A given standard vector for 2 components 1, 0, 0, 1. That's the thing. But the thing is, the next point is very, very important. Using U1 transpose of x is equal to 0, we use no. that using that formula, what are the vectors are finding, that must definitely these two vectors are orthogonal to u1, because we are finding vectors w1 w2 based on u1 transpose into x equal to 0. From this concept, what are the vectors we get, w1 w2 is orthogonal to u1 100%. That is why what we get w1 w2 is orthogonal to what actually right now is not there, is orthogonal to both u1 w1 is u1, but it is not orthogonal to itself. Therefore, how to proceed? What are the two vectors are not orthogonal, you pick it separately, apply Gram-Schmidt process to convert both the vectors are orthogonal. That process itself is conversion of orthogonal. Therefore, what we are going to do, y1 is equal to w1, yeah, first initial value, and w2 is nothing but what actually y2, I am taking new vector, y2 is w2 minus inner product of w2 comma y1 divided by inner product of y1 into y1. Using Gram-Schmidt process, you get y1 y2. I take a new y1 y2. Find out inner product of these two, definitely 0. Now therefore these vectors are orthogonal. Now this is okay, we find out by using Virginia formula AV1 by sigma 1. Other two we find out from the Gram-Schmidt. y1 and y2 we are finding these two orthogonal vectors from the Gram-Schmidt. Now if you want to orthonormalized vector means you have to normalize the corresponding vector u2 u3. We discuss in the Gram-Schmidt process. Keep in mind, any vector you are convert non-orthogonal vector to orthogonal vectors using Gram-Schmidt process, where you must be take care for that both the vectors is not normalized. Keep in mind, this is very, this vector we did different. This vector we get from the Gram-Schmidt process, non-orthogonal to orthogonal, that is not normalized. We must be normalized before going to take u1 and u2. Now this way I have to take this. If we want to, now we have to take this u1, u2, u3, where in u, and then you multiply it with u delta v transpose, then we get a. Now this is a extra points. Therefore, even though I solved one problem in previous talk, I am solving another one problem on the board. Yeah. Then another one important problem you have where actually usually they are going to ask this problem. Okay. I am going to consider third one problem. After that, I am going to wind up the singular value decomposition. Find a singular value decomposition of A equals 3, 2, 2, 2, 3, 2, minus 2. Now here, first you find out A transpose into A. That is, you know how to find out. It's not necessary to explain 2, 3, minus 2 into the 3, 2, 2, 2, 3, minus 2. Now what happened? After you multiplied, I am writing directly the value because you know how to multiply row into column 17, 8, 8, 17. And then I have to find out the eigenvalues based on this minus lambda. Order of the matrix of identities 1, 2 cross 2 is nothing but after you write this equal to 0, simplify that, we get two roots. One is lambda 1 is 25, another root is 9. I am not going to do that part because you know how to do it. Next is using lambda 1 is 25, you find out corresponding eigenvector. The corresponding eigenvector for lambda is 25 is 1, 1. You do it because you already know that x2 is equal to lambda 2 is equal to 9. From this corresponding eigenvector is 1 minus 1. 1 minus 1. These two vectors we get. Once we get the vector, you verify definitely these two vectors are orthogonal. Yeah, 1, 1 and then 1 minus 1 we get 0. Now is these two orthogonal, while taking v1, v2 then I have to do the normalize x1 divided by norm of x1 and v2 is nothing but x2 divided by norm of x2. Okay. Now you frame capital V. Capital V is nothing but what we get actually norm of x1, norm of x2 we get root 2 only. Now we get 1 by root 2, 1 by root 2, 1 by root 2 and minus 1 by root 2 we get. Yeah, minus 1 by root 2. Now, after that you have take it what is sigma 1 and sigma 2. Sigma 1 is square root of lambda 1 is 5 and sigma 2 is nothing but square root of lambda 2 is nothing but 3. Okay. The next is I have to frame diagonal matrix. What is diagonal matrix? 5, 0, 0, 3 based on the non-zero singular values. And then from that you take D. What is D? Delta is nothing but 5, 0, 0, 3, but you need one more rows because number of rows in A is 3. Therefore, this is nothing but D. And next you have to construct U1, U2, U3. What is AV1? While finding AV1, yes, what we get actually? AV1 is 5, you know that you substitute A value, substitute V1 value, you know V1. Substitute, then we get 5 by root 2 and 5 by root 2 0. I am writing only the final step because you know how to multiply. Similarly, you take AV2. From AV2, you calculate this substitute A and V2 value. Finally, we get AV2 value 1 by root 2 minus 1 by root 2 and 4 by root 2. We get this. Okay. And then you find out U1. What is U1? Delta AV1 by sigma 1. And then U2 is nothing but AV2 divided by sigma 2. AV1 divided by sigma 1, after that we get 1 by root 2, 1 by root 2 and 0, because I have to divide by 5. And then similarly U2 is nothing but AV2 divided by sigma 2. Sigma 2 is 3. Once you divide and simplify that, we get AV2 is 1 by 3 root 2 minus 1 by 3 root 2, 4 by 3 root 2. Yeah, but need one more. What is one more? How many rows you have? 3 rows. Number of unit vectors must be equal to number of rows of the given matrix. Still I need U3, but we have only a 2 singular values. Now, you have only 2 singular values, only we get U1, U2. I want to find out another one more, what about that, one more value here. Therefore, if we want to find out one more value, I told already U1 transpose of x I am going to find out equal to 0. Therefore, why I have taken this, I will explain based on that. Here one component 0, other two is not equal to 0, but till all the components are non-zero. Suppose you take U2 transpose x is equal to 0, we get x1 plus x2 plus x3. But here we get only x1 and x2. That is why I am writing like that, using this simple one U1. U1 transpose of x is 0 means 1 by root 2, 1 by root 2, because I need to find out another U3 into x, x1, x2, x3 equal to 0. What we get? 1 by root 2 into x1 plus 1 by root 2 into x2 must be equal to 0. From this, what happened? Now here we get x1 equal to minus x2. x1 is equal to minus x2. That implies what is my w1 is nothing but 1 minus, take it in the column 1 minus 1 0, x3 0, 1 minus 1 0. You only have x1, x2. What's the value of x3? x3 is 0. This is, we get automatically one vector. Now keep in mind this vector, what we get this vector, yeah, this vector definitely is orthogonal to yeah, you know that inner product of u1 comma u2 definitely 0. If you want to find out, definitely 0. Inner product of u1 into w1 definitely equal to 0. Yeah, because what is u1? u1 is 1 by root 2, 1 by root 2, 0. What's another one is 1 minus 1 0, because we are finding based on that definitely 0. But inner product of u2 comma w1 is not equal to 0. What is u2? Inner product of u2 is 1 by 3 root 2 minus 1 by 3 root 2 and then 4 by 3 root 2 into w1, 1 minus 1 0. Multiply that, definitely Now once you multiply that, what we get? 1 by 3 root 2 minus into minus plus 3 by 2 is not equal to 0. Is not equal to 0. Again you pick u2 and w1. I will give hint. You pick u2 and w1, apply Gram-Schmidt process. Once you apply Gram-Schmidt process, u2 is, I am taking u2 is, sorry, I am taking y1. y1 is nothing but u2, and then y2 is nothing but y1 minus inner product of, sorry, what is the w1 minus inner product of w1 comma y1 divided by inner product of y1 comma y1 into y1. Yes. Using this you find out y2. Once you get y1, y2, definitely this is y2, what we get after this step, y2 is, yeah, y2 what we get, I am going to write it on the board, y2 is nothing but, yeah, u3 dash after the substitute and simplify, then u2 what we get actually, u2 is nothing but, yeah, 8 by 9, yes, minus 8 by 9 minus 4 by 9. You do it, I will written on the board, you do the calculation, we get this. Once we get these values, what we are going to do? Once we get these values, what we are going to do? Now keep in mind here u1 is equal to u1, u2 is equal to u2, but while taking u3, u2, y2 norm of y2. Keep in mind, that is why I want to explain this, that is why I taken this problem. Keep in mind for this problem we get u1, u2 directly. You do not get it u3 because number of rows is 3. Therefore, what I did, I taken u1 transpose into x is equal to 0. From that we get w1. While taking w1 along with u1 is 0 because we find out based on u1, but is along with u2 is not 0. Therefore, what I did, I taken u2 and w1 is separate, apply Gram-Schmidt process. Now I taken u1, y1 is u2, next y2 is, that's then I want to return u2, that's why I taken initially my x1 is u2 only, and y2 is nothing but w1, this using this formula you calculate, we get y2. Now once you get y2, find out the inner product between y2 and u2, definitely 0. Because using Gram-Schmidt based on this we are finding, no, therefore inner product of u2 comma y2 must be 0. Definitely inner product of y1 comma y2 must be 0. And next you have to take unit vector, u1 is u1, u2 u1 you find out using usual formula av1 divided by sigma 1, but y2 we get from Gram-Schmidt, that only Gram-Schmidt convert our vector non-orthogonal vector to orthogonal vector, but it is not convert to directly normalized vector, means orthonormalized vector. Therefore, what are the vector we are convert by using Gram-Schmidt process, you must be normalized. Therefore, u3, what is y2 divided by norm of y2, and then you frame u, what is u, u1, u2, u3, and then you multiply u delta v transpose, we get a. This is also another different type of problem, must be taken. Before going to wind up this class, I'm once again explaining that what are the non-orthogonal vectors we are converting to orthogonal vectors using Gram-Schmidt process, means that is not normalized, you must be normalized. But u1, u2 we have taken different formula, av1 by sigma 1, av2 by sigma 2, not necessary. Now that's why must be take care, right to solve. Usually they are going to ask such type of problems only in the exam. Then okay, thank you very much for listening. All different type of problems are discussed, totally 3 problems apart from the previous class. This is a singular value decomposition problem. There is a way to solve that. Thank you very much. Okay.